Okay, we're going to look at how to use dbt with the Fabric Spark in a production CI/CD manner. So basically, I'm going to have a Fabric workspace where we've got our dbt seed tables. So for example, this is my dbt. Um, we are going to have, let's say this one, the AdventureWorks model, where we have some data that's been seeded, let's suppose from Spark. So, for example, these are the kind of tables that we've ingested via some other means. So, in this case, I'm just pretending that this data was coming in from Kafka and we have it loaded into Silverware via Spark. So, what we're going to do is we're going to set up a local VS Code dev container end to end completely. We're going to mount this Silver One Lake using something called BlobFuse in a read only fashion. And then we're going to run dbt against this model via a Livy server that we're going to have in the VS Code dev container. And we're basically going to be using something like AI to write the dbt code. That's going to write our gold tables into our local meta store. We're going to query it. And then the idea is, we can take this branch, put up a pull request into a GitHub action, run the exact same test that we ran locally end to end. And then when we are ready, we're going to go ahead and merge it into the main branch, which is going to package up our code, push it into Fabric, and then we're going to run dbt in Fabric in order to basically generate the exact same models, except we can process data a lot faster because we have bigger computers here compared to what we're running. So to start, I'm going to go ahead and open up a small dev machine where I've got this Git repo, which is cloned on my main branch. So I have some steps here on how you can go ahead and get set up with the dev container. So the first thing we do is we run this bootstrap script, which basically goes ahead and blows up your old WSL machine if you have it, and then it basically spins up a new one. So I'm just going to pause here. It takes about 30 seconds. Okay, so we've spun up a new WSL machine. Now what I'm going to do is inside of the WSL, I'm going to clone this repo, the exact same repo, just inside of WSL. Okay, so I'm just going to put my first name, last name in, and then we're just going to clone that branch. Okay, so we're now launching VS Code inside of this WSL. And finally, I have a script inside of the WSL itself, which is going to install the prerequisites required in order to work with the VS Code dev containers, like, for example, Linux and whatnot. So I'm just going to go ahead and close all of this, and then just running this inside of the WSL machine. And right now it's going off to apt and installing a bunch of things. Like basically we're just installing a few things that we need in order to work with VS Code dev containers. Okay, since we're going to be mounting One Lake into this dev container using Azure CLI, I'm just going to log in with my Azure CLI. Okay, awesome. So that's pretty much it. So now we're ready to go into the dev container, which has Spark, Hive, Livy, and everything installed. So we just need to go ahead and launch the VS Code dev container inside of this WSL machine. It's going to pull the image from Azure Container Registry, which is going to take about 2 minutes. So basically, this is the only first time setup you have to do, and then essentially you can just keep going off using the dev container over and over again as many times as you need. And because the list of dependencies that we've installed is so small, like basically inside of the Windows machine, all we need is a WSL, which is very lightweight. It comes with Windows already. And then inside of the WSL, we don't need Spark. We don't need anything heavy duty. We're just installing Docker and we're installing the Azure CLI. That's pretty much it. And then everything Spark, Livy, Hive, it's all built into the dev container. So while the dev container is getting pulled and spinning up, essentially what we're going to do when we're in the dev container is it's already going to have a SQL Server backing the Hive metastore. It's going to have a Hive API, and it's going to have Livy with Spark all ready to go. We're essentially just going to go ahead and fire dbt, which is initially going to invoke BlobFuse so that we can mount One Lake into our local dev container. So essentially, we're going to be mounting these production silver tables that we saw in the Fabric workspace into our TMP folder as a read-only mount. So as far as Spark is concerned, it's going to seem as if you have a local Delta table, but in reality, it's being backed by One Lake. So it's pretty cool. And then we're basically, just going to be running the dbt run command, which I think most of us are familiar with. And then it's going to basically go ahead and rip through the model and then hydrate the data that we're interested in. Okay, so now the dev container is up, and it uses Node.js as a package management. That's not relevant, but basically we're just installing Hatch, making sure Python is all booted up and things like that. the dev container is ready. Now we see that Livy is up, and we can see that we're running Spark locally, and these are the kind of settings. Cool. So now we just need to actually run one setting in order to run the entire development stack. So if we go to the Spark TPD project, which is over here, projects, Spark DBT, and I'm going to go here. So basically, let's say we want to go ahead and run the AdventureWorks model. So there's a target here that I'm going to run, and it's basically going to go ahead and mount the OneLake tables. Oops. Okay. So I need to do the initialization. So let me just run the test. I think it'll be easier because it's got the dependency for the virtual and dependency built in. There we go. So basically, this is not relevant, but the way this test works is we need to do the initialization of the hatch environment, and then once that's done, we need to mount the OneLake tables. And then once the OneLake mounting is done, we're going to go ahead and run DBT. So I'm just going to pause, and as this kind of progresses to the logical stages, I'll unpause to kind of walk through this, what's going on. Doing this is probably going to take about 5 to 10 minutes in order to create the venv, mount OneLake, and whatnot. And we can also see that a small SQL Server Linux container has come up, which is basically serving our Hive metastore over here. So in the meantime, we can see that DBT has kicked off. And this is just doing the debug command. We have two DBT projects, which is why it's running kind of both of them in parallel. So you can see I've got a Jaffle shop and an AdventureWorks. They're both running in parallel. And we've connected to the local Livy API, and we're firing the DBT build. In the meantime, you can notice that we actually have access to OneLake locally. So this is where the code went ahead and did a mount. So basically the same tables that we're looking at in Fabric, this exact same Delta tables, right, are available inside of our local Spark container using blobfooz and AZCLI. So now the models are just going to go ahead and refresh, which is just usual kind of DBT commands. So while that's running, let me just show how the blobfooz is working. So basically, we mounted two different lake houses, and the way each of them were mounted was using this kind of OneLake ID. This is the ID of the lake house, and we basically mounted it to this TMP MNT folder. So yeah, DBT is going to go ahead and run, and it's going to run green at the end. And essentially what's going to happen is we're reading from OneLake, but we are writing to our local file system. Because we want to go ahead and blow up our local file system and rebuild the model or whatever as much as we want. So for example, you can see here that the Jaffle shop has gone ahead and created the customers and orders Delta table locally. And the AdventureWorks is going to go ahead and do the same. And when this is done, this is basically going to finish running. So while that's happening, let's go back to your diagram. So I went ahead and used AI or whatever to write these DBT models, and now I'm ready to kind of go ahead and open up a pull request. So what I'll do is I'll basically take this branch, whatever the business logic is in that branch, and I would go ahead and open up a pull request. So a pull request like this, for example, right? I'd have a bunch of files changed. And the idea is the same code that was running locally where we fired that test command where we're basically doing a full build of the DBT model. We want to make sure we go ahead and do that inside of GitHub Actions as well, such that we're able to catch regressions in our, any business logic or what have you, or our tests, right? So basically, this is where that same PR would go ahead and fire off a GitHub workflow. I can show the GitHub workflow real quick. It's just over here. Nothing kind of extraordinary. We're just spinning up Spark in the same dev container, and then we're firing the test target that we just saw. So I'm going to go back to GCI. And we can see we're basically just doing the same thing that we did locally, those same kind of Livy startup commands, and we're just running build, lint, and test, essentially. And that's going to go ahead and fire the DBT under the hood. And that PR was basically, running a pipeline like this. You can see it took about 13 minutes end to end. And if I were to click on the steps, you would notice that it's basically go ahead and kind of doing the exact same things that we're just doing locally. It's the exact same dev container, except it's running the tests inside of this kind of GitHub machine. And then, when this test is done running, we can see that it's the exact same set of tests. So let me just zoom in here. And I have full confidence that whatever we're doing locally right now is going to run in GCI and vice versa, because like the code is the exact same, and there's kind of no chances of any drift happening, right? So then I would go ahead and merge this pull request. So let's say I go to this pull request, I would merge this pull request after review, after it runs green, and then we would go ahead and like package up our DBT project. So have a little package script here, and then we can push this bundle into OneLake where we can run a little notebook that I created in order to basically wrap the DBT runner. So if I go to Fabric, let's go to this DBT POC. So basically, I have this little lake house. I just called it DBT infra. This pattern doesn't matter. You just need to get your hands on a zip file that contains your DBT infrastructure, and then you just need to get it to a Python notebook. So in my case, I just zipped it up in a targz, and I have this little pipeline which basically goes ahead and wraps a Python notebook which has the DBT entry point. So if I go ahead and show the view run history, so for example, I go here, this is where we're going to use this kind of lightweight Python notebook in order to invoke DBT against a large Spark cluster, like whatever size that you need in order to run the exact same DBT command. So let's just wait for this to load up. Okay, so we can see that that same notebook would basically just go ahead and install, except it would do the installation from OneLake. Basically, I put the wheels and everything in, so I don't have to like go off to the internet and install some versions, and then we're just going to go ahead and run our DBT projects in parallel, similar to what we're doing locally. And then at the end, I'm just going to kill the Livy session, so we're not leaving Spark running for longer than it needs to. That's it. So basically, that kind of takes us to the end of this flow, and that would basically let us just kind of generate our business value or whatever gold data that we need to. So the next step after this, right, is we spent time setting up all this infrastructure in order to make sure that we're able to have robust dev testing available. The next logical step is, rather than me going into VS Code and kind of vibe coding with AI, I can take that a step further and basically like let AI kind of do this dev testing on its own using GitHub Actions or Azure DevOps pipeline. And then what I need to do is basically, instead of me being in the loop with the coding, I can just go ahead and make sure that I'm orchestrating the AI in the best means possible. And because everything is kind of tested using like real production data in a read-only format, whatever code this AI puts up, I can be very confident that when I start merging any of these PRs, I'm able to have like full regression test coverage, and I know exactly what data I'm going to be serving up in front of my stakeholders. Yeah, that's pretty much it. It's a pretty decent environment to go ahead and do your development in, and just you can see that right now we're just running like the DBT unit tests in this particular model. Yeah, thanks.